So this is the first question on connected rates of change, a more challenging one to the standard questions. I recommend pausing the video and having a go at this question, and then when you press play, I'll be going through it. When I go through it, I recommend opening up a new tab with the same video so you can have this question side by side in your browser so you can refer back to the question as I go through it, as that might be helpful.
So in the first part of the question, we have to prove that for any given height in this funnel, the volume is 1/9 pi h cubed. That result is given to us, but we have to prove it in the question. Now, you're kindly told in the question that the volume of a cone is 1/3 pi r squared h. So the volume of the liquid of this mini cone, if you like, contained in the bigger cone, would be, using that formula, 1/3 pi r squared h, as given in the question. But you notice what they want is they want a formula for volume just in terms of h. So it must be that you use this 30 degrees. Why have they given you that 30 degrees? So if you link those two ideas together, I need to get a formula just in terms of h. I've got r and h, and I've got 30 degrees. So clearly we're not allowed to have r in our answer, and the way to get rid of r in our answer must be something to do with this 30 degrees. So the clever little trick here is to recognise that the height and the radius are right angles to each other. This is a right angle triangle, because this is a horizontal radius and this is a vertical height. So that forms a right angle triangle. So we can use trigonometry, basic right angle trigonometry. We can use tan. Tan 30 is the opposite divided by the adjacent. Now, tan 30 is 1/√3. And remember where we're going with this, we need to get rid of r. So to get rid of r, pass the h up, r would be h/√3, but I need to get r squared. So whilst I'm at it, I might as well find an expression for r squared. R squared would be h squared divided by 3. Square the top and the bottom there. Insert that in there, and we should be able to get this expression. Let's see. V is 1/3 pi h squared over 3 is what I will replace r squared with. There's another h there. Now look, you've got 3 and 3, two denominators of 3, which will combine to produce 9. On the top, I've got 1 pi h cubed, and that's exactly what I was looking for. So that's part A of the question. Right, before you get into part B, there's a sentence that says that the volume of water in the funnel increases at a constant rate of 200 centimeter cubed per second. Remember, we said the rate of change of something is differentiation with respect to t. It says in black and white in the question that it's the volume of the water that is increasing at a rate. So this must be dV by dt. We're told that the rate of change of water is increasing, so dV by dt is positive. So the 200 would be a positive dV by dt. Remember, I think an easier way of noticing that is looking at the units. If they give you some information that represents a derivative, look at the units. It's a volume per time. That's dV by dt. So dV by dt is 200. And we remember, for these rates of change type questions, you split out the derivative of volume, the time derivative of volume, or the time derivative of surface area, or the time derivative of cross-sectional area, into dV by whatever the letter that is being used in the question. Notice in part A, we had r and h, but we squashed them together so that we only have to deal with h. So I'll write it as dh multiplied by dh by dt, and let's fill it in. dv by dt is 200. Remember how you're absolutely sure that the middle derivative has the right letter on the bottom. This derivative here, the middle one, must be the derivative you can physically differentiate. Therefore, if it's going to be dv by dh, it means I need an expression for v in terms of h. We had that in part A. Had I got v in terms of r, this would have been dv by dr, this would have been dr by dt. However, there's another way that we can know it must be h, because look at what the question's asking you to do. It wants the rate of change of the depth when h is 15. Notice the depth is h. It wants the rate of change of depth. Remember, rate of change is differentiation with respect to t. The depth is h. They're asking for dh by dt. If they're asking for dh by dt, then this has to be h. You can't have dv by dr multiplied by dh by dt. That's not correct, and there's too many letters there. So this is correct. So dv by dh is differentiating this. That's 3 over 9. Obviously that cancels. We'll do all that in a minute. Pi h squared. And dh by dt is what we're looking for. So let's just leave that. Right, that's a third. I'll bring the 3 up and I'll divide by pi h squared. So we get dh by dt is 600 divided by pi h squared. That's the general rate of change of depth. They want in the question the rate of depth when specifically the height is 15. So we now need to substitute 15 in here. So, sorting that out, we get 600 over 225 pi. At this point you need to reread the question. Does it want this rate of change to 3SF, something like that? Or does it want it to or does it want it as an exact multiple of pi? In this case it wants it as an exact multiple of pi, so you just need to simplify this. You can actually divide top and bottom there by 75, and you should get 8 over 3 pi. Give it a unit. H is depth, that's measured in centimetres in this question, could be metres in another question. T is time, again it's measured in seconds, that could be hours, and that's the final answer.
Okay, well done if you got the first question correct. This is the second question. Once again, pause the video and have a go. And when we go through it, I recommend opening up a new tab with the video so that you have this tab available with the exam question to make reference to it if you need to as we go through it.
So in this question, the first part of the question asks us to prove that the volume of liquid contained in this funnel for a specific height h is given by this formula. Now the question kindly tells you that the volume of a cone is 1/3 pi r squared h, which is obviously something we've met before at GCSE. So the volume of this cone, which is the cone we're looking for, is 1/3 pi r squared h. So how do they give you this formula here? First thing to do is actually, even if you can't spot exactly the path to get this question complete, is to think what we have and what they have, where we are and where we need to go. So this formula here, the volume is just in terms of h, whereas our volume is in terms of r and h. So it must be that I'll solve this question by eliminating r. But there's another factor we haven't discussed yet. They've given us this 16 and the 24. There must be a reason why that 16 and 24 is there. Not just must there be a reason, it's crucial to use this information, because how else are we going to eliminate r and h? You have to be very, very observant what is given to you in the question. So, let's have a look. Something to spot and to recognise is that a mini cone, i.e. a cone that is inside another cone, will be similar. That cone here and the big cone are similar shapes. A triangle within a triangle where they share an angle at the bottom, similarly, will be similar shapes. So a cone completely inside a cone where they share the apex of the cone will be similar. In other words, these lengths are similar lengths. In other words, what we could say is we could say 16 and R and 24 and H are in the same ratio. So 16 divided by R must be the same ratio as 24 divided by H. That relationship will be the one that gets rid of R, and we can get the volume just in terms of H. So if we want to get rid of R, let's eliminate R. So if we cross multiply, we get 16H is 24R, and therefore R is 16H divided by 24. Divided by H. That relationship will be the one that gets rid of R, and we can get the volume just in terms of H. So if we want to get rid of R, let's eliminate R. So if we cross multiply, we get 16H is 24R, and therefore R is 16H divided by 24. 16H over 24 can be simplified because you can divide the numerator and the denominator by 8. So that simplifies to 2H over 3. And now we have a relationship between R and H. So now I can insert this into there. And if you do that with a bit of simplification, you should be able to get this. So let's do that now. We said R is 2H over 3. Let's insert that in here. We get 1/3 pi. All of this needs to be squared. So let's use a bracket. Right, now we just need to expand this out. Let's expand the bracket out first. Remember, the squared is on the top and the bottom. So if you square 2H, you get this. Then combine that H with that H. You get 1/3 pi multiplied by 4H cubed over 9. Then combine the denominators of 9 and 3, which combine together to produce 27. The 4 on the top will stay there. So we've got 4H cubed pi all over 27, which is exactly what they have there, except they had the pi before the H cubed. So then I would write another line of this, and that's a complete proof to produce the volume as 4 pi H cubed over 27. We're told that water flows into the funnel at a rate of 8 centimetres cubed per second. We need to translate that into maths. Remember, the rate of change of something is something with respect to time differentiation. So the rate of change of the volume of the water means that this is a dV by dt. Now, again, look at the units for another clue. 8 centimetre cubed, that's a volume per time, so it's dV by dt. Remember, the rate of change of something is something with respect to dt, and the top, the numerator of the derivative, as it were, must be whatever the rate of change is. So in this case, it's the rate of change of volume, so it must be dV by dt. Again, also just check that dV by dt is positive, because the rate of change is increasing by 8, it's positive 8. If the funnel was losing 8 centimetre cubed every second, then it would be a negative answer to dV by dt. Now, we produced the formula V equals 4 pi H cubed over 27 in part A, so we split out the derivative dV by dt as dV by dH multiplied by dH by dt. Remember, the middle derivative is the derivative you should be able to do using differentiation. So therefore, I know it must be dV by dH because I've got a formula for V in terms of H. So, dV by dt I know is 8. dv by dh we can do. We can differentiate this expression. Bring the 3 down, so that becomes 12 over 27 pi h squared. Notice the question asks you to find the rate of change of h. So it's asking you for dh by dt. There's enough evidence to suggest that we know it must be dh here and dh here. Let's rearrange dh by dt now. So let's bring up the 27, let's divide by 12, and we'll also divide by pi h squared. So let's just tidy that up. So dh by dt simplifies quite nicely. It becomes 18 over pi h squared. It asks to find the rate of change of h actually when h is 12. So we now need to input 12 in here. So that's 18 over 144 pi. Now we check the question, does it want this to significant figure accuracy or does it want it in terms of pi? And it wants it in terms of pi. So I can just have to simplify 18 and 144. You can divide 18 and 144 both by 18. So the answer is 1 over 8 pi. Again, given answer. It's centimetres because it's the h. A second. Which means the depth of this funnel is increasing at a rate of 1 over 8 pi centimetres every second. So that volume of liquid is going up at 1 over 8 pi centimetres every second. It's increasing by that amount.